I admit it. I like dogs. They're such happy creatures. Last time we found out how we can use 40H or Ford to reproduce the ZX Spectrum beep programs from our youth. Yeah, that wasn't very impressive, like a kid playing his first song on a piano. But it was good enough to go looking for more programs. I went looking on the internet, but found only one. An old Russian children's song called Lisura Dile Sholitska. That was a bit disappointing. And with just a piano, it didn't sound quite right. So I decided to tackle that one first. Fortunately, there are a lot of Midi instruments. 128 to be exact. Oh, that promised days of fun. Очень хорошо, товарищ. And best of all, it's just another Midi event. Just 3 bytes. No sweat. You can even switch instruments during a song. Great! In the meanwhile, I kept looking for more songs. No, I didn't encode them myself. I'm as much a musical genius as my dog, rest in peace, was a capable Rust programmer. And then I found some Arduino programs by Abhishek Ghosh. It wasn't using a beep notation, but a tone octave notation. But I can handle that. I've coded a whole bunch of constants representing the notes, and because there's more than one octave, there's also a value to control it, called m-octave. Slight problem, m-beep ignores it. Note I couldn't find the standard where the MIDI octave numbering was concerned, so I left that one to the programmer to figure out. To me, MIDI octave 0 is where the MIDI note 0 resides. By the way, the best way to handle octaves is just to set a fixed one using 2. And then use +2 during the song to make adjustments in the sense of higher, lower. That way, if you want to change the entire setup, you only have to change the initial setting. Another thing of interest here are the rests between the notes. You can't control these using the mbeep command, it simply doesn't support it. So I created a second command, called mplay, that not only supports octaves, but also the missing rests between the notes. And just like that I could code the Star Wars theme in 40H. No, I can't play that one, they'll sue me. But Furilize offered a whole new challenge. One that used frequencies. Now of course you can reduce frequencies to notes and octaves, but you'll need a whole new library to pull that one off. And this is it. It may not make much sense at first sight, but the data represents 16-bit Little Endian numbers, divided over 2 bytes. Just like the ZX Spectrum. We'll leave it to the program to do the conversion, that's not too hard. This is a true representation of the stored data. Throw in a frequency and it'll return a note and an octave. Like 261 Hz, which is the middle C. And it returns 4, the octave, and 0, the note, which is obviously a C. But a true middle C is closer to 261.63 Hz. So, what if we round that number up to the next integer, which is 262 Hz? It will return the very same thing. It simply looks for the first entry that exceeds the input and returns the previous input. In order to speed it up a little, it determines the correct octave first, and then goes looking for the correct note. Now, how does this simple table derive both the octave and the note from just the frequency? There is no conversion data. The secret lies in the layout of the table. Once it found the position of the entry, it simply does a /mod on that offset. An octave consists of 12 notes. Hence, the slash gives us the octave and the modulus gives us the note. That easy. You can feed the octave straight into m-octave and let mplay do the rest. Isn't it beautiful? Well, ChatGPT thought it was. But I digress. In the Furilize example, we provide a rest, a frequency and a duration to a tone definition. First we put it to the frequency converter, adjust the octave slightly, and then use it to initialize the M octave value. And then we call mPlay. And that resulted in this rather ethereal rendition of the Beethoven classic. Für Elise, am 27. April zur Erinnerung von L. von Beethoven. So in short, there's a lot you can throw at this thing. Static spectrum notation, musical notes, and even raw frequencies. This thing will gobble it up without ever missing a beat. It's true, sometimes it doesn't sound quite right, and you have to experiment a little to make it sound just right. But isn't that part of the fun? I mean, let's face it, the whole idea was to breathe new life in a few 40-year-old BASIC programs. And that's exactly what we did, didn't we? So stop complaining and mail me your improvements. Come on, don't be lazy. And before we go, did it survive the uBasic 4 test? Of course it did. What do you think? It's a capable little language, you know. And ending on that positive musical note, I'm Hans Bezemer, and this was Back and Forth.
I appreciate you. You know that? Every view counts. Love you.